So in the previous videos we are just going through the chapter number 7, that is triangles. In that we have seen some of our lastly the RHS, that is right angle hypotenuse side, that theorem, and now here we have just reached to the inequalities in triangles. Okay students, let us see that. So you can see on the page number 129 it is given that so far you have been mainly studying the inequality of sides and angles of a triangle or triangles. Sometimes we do come across unequal objects, we need to compare them. For example, line segment AB is greater than length as compared to the line segment CD in figure 7.41, and in the first, and angle A is greater than angle B in the figure 7.41. To here, inequalities in triangle. Okay, so here inequalities in a triangle. You can see here, first of all, they have given the line segment, that is CD, and the another line segment, that is AB. You can see some of the inequalities in the length of this both, that is this CD is smaller than AB, or we can also say that AB is greater than CD. Okay, you can see there is a difference. Okay, in that way, in the triangle, you can see, and the secondly, it is given the angle. Here you can see the angle A. If I say that this is angle number A, and the another one, that is angle number B. So here also you can see that angle B is greater than angle A. Okay students, we can say that. And now in that, now we just come to the triangles, inequalities in triangle. So let us see equalities. So in your textbook there is a diagram given that I am just drawing over here. Here it is given a straight line over like this, and from here, okay, so you can see there is a variation. It is given, if I give a point over here, if I say this is, I am not giving the angles, I am giving the point, that is A, B and C. Okay, then after, if I draw another line from here, then if I say here D, if drawing from here, okay, then E. Okay, so in this way you can see there is a difference between the triangle ABC, DBC, EBC. So this is the inequalities in the triangle. We know that as the angle or the length of the side changes, the triangle will be unequal to each other. Let us see some of the theory. You can see, let us now examine whether there is any relation between unequal sides and unequal angles of a triangle. For this, let us perform this activity. Activity: fix 2 points on a drawing board, say at B and C, and tie a thread to mark a side BC of a triangle. Fix one end of the another thread at C and tie a pencil end at the other end, free end. Mark a point A with the pencil and draw triangle ABC. Now shift the pencil and mark other point A prime. Okay, and then after CA beyond A, so new position of it. So A prime C is greater than AC. Comparing the length, join A prime to be the complete of the triangle A prime BC, what can you say about triangle angle A prime BC and angle ABC? Compare them. What do you observe? Clearly, A prime BC is greater than angle ABC. Okay, continue to mark more points on CA and draw the triangles with the side BC and the point marked. You will observe that as length of the sides AC is increased, the angle opposite to it, that is angle B, also increases. Let us perform another activity. So here in this activity, what they have done, you can see here, first of all, they have given another name, I have also given another name. Okay, so first of all, they have told to just put it in the cardboard, the pins, and then after you have to draw that. So I am just explaining in the simple language. So if you just take the triangle ABC of some length, and then after you just take some length from over here A and just draw a straight line from that, then we can obviously say that triangle or angle BCB is greater than angle ACB. Okay, ACB. We can say that this is greater than this, and also we can say that triangle ECB is greater than DAC and ACB. We can tell that also. Then moving further, here construct a scalene triangles in which all the sides are of different length. Measure the length of the sides. Now measure the angle. What do you observe? In a triangle ABC of figure 7.43, BC is the longest side and AC is the shortest side. Also, angle A is larger than angle B is the smallest. Repeat this activity with some other triangles, and from that you can see we can just find out a theorem, that is theorem 7.6, that is if two sides of the triangle are unequal, the angle opposite to the longer is larger. Okay, first of all, just doing that scalene triangle over here with the different length. So here you can see a triangle is given, that is A, B and C. Okay, then here what they are telling in next theorem, what they are just telling in theorem which is 7.6, in the theorem 7.6 it can be said that the angle which is the larger side angle, means the length which have larger side, that is CB, that is larger than opposite to that angle, means this angle will be larger. This angle will be larger. The larger or the length which is the in the length that is which is the highest, then its opposite angle will be more. Okay, students, and from that you can see a theorem is given. Let us see that, and first of all draw a drawing of it one by one. So first of all the theorem, that is I am just writing that on the board, that is 7.6 theorem 7.6, that is if two sides of a triangle are unequal, the angle opposite to the longer side is larger. Larger or greater, here it is given. So first of all, if two sides of a triangle are unequal, the angle opposite to the larger side is larger. Okay, then what they are telling, if I draw a triangle, line segment, that is line segment AB. If I draw a line segment AB, and from that from here I just put an arc over here, then see here in your textbook the arc is given from the A. Here you can see arc is given like this. Okay, I can't draw perfect, but I have drawn good. Okay, then after you just have to join one point from here. So if you just draw, okay, a point from here, and if I just give a name P, okay, and if I just join this, you can see which one is the larger side. But from here you can see all the sides are equal. Now I am just taking a point over here, that is Q. Okay, that is Q. Then now if I join this one over here, then you can see this QB is larger side. So opposite to that means here it will be, this point angle will be larger. Okay students, and then after taking the another point from here, okay, R, if I just give a name, that is R, and then after if I just join this, okay, then you can see this one is larger, so the angle will be also larger. In that way it will just go on. Okay, the figure is given now. If I just go this side, then what will happen? This length will be increased and this angle will be increased. Okay students, so this way it is given. If two sides of triangles are unequal, the angle opposite to the longer side is larger. Means the larger angle which is, then the opposite to that it will be larger angle. Then you may prove this theorem by taking a point P on BC such that CA is equal to CP in figure 7.43. Okay, you can also take that an activity is given, that is draw a line segment AB with A as a center and some radius. Draw an arc and mark different points, say P, Q, R, S, T, and then after join each of this point with A as well as B, and then after observe that as we move from P to T, angle A is becoming larger and larger. What is happening to the length of the sides opposite to it? Observe that the length of the side is also increasing, that is TAB is greater than angle SAB is greater than angle RAB is greater than angle QAB is greater than angle PAB and TB is greater than SB, angle SB is greater than RB and angle RB is greater than QB and it is greater than PB. Now draw any triangles with all equal angles unequal to each other. Measure the length of these sides. Observe that the sides opposite to the largest angle is the longest. In figure 7.45, angle P is largest angle and AC is the longest side. Okay, repeat this activity. Just moving further, you can see another theorem is given. So let us see. First of all, you just read it. Theorem 7.7, that is Theorem 7.7. In any triangle, the opposite, the side opposite to the larger angle is longer. Okay. Here our theorem, that is 7.7, in that we are just telling in any triangle the side opposite to the larger angle is longer. In previous theorem, what we have studied? We have studied that the side which is longer than opposite to that, there is a larger angle. In this, what is that in a triangle? The side opposite to the larger angle is longer than. In first, what they are telling? In the first theorem, that is 7.6, they tell us that the line which is larger opposite to that angle is larger, okay, or greater. And in this theorem, that is 7.7, that if the angle is larger then opposite to that a line segment which is there, it is longer. So both are same only, but they have just tell in the different language. That first of all, what they tell us here, I am just reading that theorem. That is, if two sides of a triangle are unequal, the angle opposite to the longer side is larger. And in this, that is in a triangle, the side opposite to the larger angle is longer. Okay, they are just telling opposite to us. Now just moving further, and you can see and another theorem is given. So let us see that. Here, new theorem, that is 7.8, that is the sum of any two angles, sides, not angles, sides of a triangle is greater than the third side, then the third side, okay. Now in this theorem, that is 7.8, the sum of any two sides of the triangle is greater than the third side. Here, if I say that it will come in the next classes, that you will know that it will ask that this is triangle or not. In some triangle, it will given the length. If I say that, if I drew a triangle, then here it is 3, 4 and 5. The length is given. Then what they are telling, if this is a triangle, then it will be what? It will be the sum of any two sides of a triangle is greater than the third side. Means if I just say that ABC, triangle ABC, if I do plus, that is AB plus BC, AB plus BC, okay, then it will be 3 plus 4. Here 3 plus 4, that is 7, and that is greater than AC, which is 5. Okay, and then after, if I say that angle AC plus BC, okay, then AC is 5 and BC is 4, then it will be 9, then which is greater than AB, which is 3. So you can see the condition satisfied. And the third one, that if AB plus AC is given, then after AB is here 3 and AC is 5, then it will be 8, and which is greater than BC, that is which is 4. Okay, you can see it. If in the triangle the two angles, any two of the sides which are sum, the sum of the two sides is greater than the third side. Okay, students, and see here, if I say that this is not same, the triangle which doesn't satisfies this condition, that is here, if I say a triangle, here it is length 1, here it is 5, and here it is 4. So let us see this is triangle or not. Then here 1 plus 5, if I give name A, B and C, then if I say AB plus AC, that is 4 plus 1, 5, then is equal to, here I have to write 1, then that is 5, and which is equal to BC, that is also 5. And let us take another one. Then if I say angle AC plus BC, then it is 1 plus 5, that is 4, then which is greater than AB, which is 4. You can see here it is equal to, here it is greater than, and another, if I take 5 plus 4, then it will be 9, which is greater than, then this triangle can be formed. Okay, then after, if I just change some of the digit, if I change here digit, if I say here it is 3, here it is 2, and here it is 1, then here also if I say here it is also 2, Okay, let us see that it can be or not. Then I will say that AC plus AB is equal to 2 plus 2, that is 4, which is greater than BC. And if I say AB plus BC, then it is 2 plus 1 3, which is also greater than AC. And if I say that AC plus BC, which is also 2 plus 1 3, which is greater than AB. And if I just do here, in place of 2, if I take 1 over here, then let us see what is happened. So here if I say AB plus BC, AB plus BC, that is 1 plus 1, that is 2, you can see. Then this is equal to AC. Then after if I say AC plus BC, that is 2 plus 1, that is 3, which is greater than AB. So you can see some of these triangles satisfied and some of the triangles do not satisfy this theorem. Okay students, moving further, and you can see over here some of the theory is given of this theorem. I will just read that. Here, the sum of any two sides of a triangle is greater than the third side. In figure 7.46, observe that the side of BA of a triangle ABC has been produced to a point D such that AD is AC. Can you show that angle BCD is greater than angle BDC and BA plus AC is greater than BC? Have you arrived at the proof of the bottom of the theorem? Here some of the examples are given which we don't have to calculate, and here it comes directly the exercise and which is cutted, so we don't have to do that. Here we have just completed the chapter. Okay students, so in today's homework what you just do is in homework theorem number 7.6, 7.7 and 7.8. 7.6, 7.7 and 7.8. Okay, this three you have to write down in your homework, and we will meet in the next video. Bye students.